Good day, everyone. Thank you for joining today's Docker webinar, Docker on Windows from 101 to Modernizing .NET Apps. A few housekeeping items before we get started. Please note this session is being recorded, and a copy of the recording will be sent out to you a couple days after the webinar. We will take questions at the end of the session, so please type them in the Q&A window, which is located in the lower right of your screen underneath the chat window. Please put your questions in the Q&A window, and our speaker will address them at the end of the session. I would now like to introduce our speaker, Elton Stoneman, Developer Advocate at Docker. I will now turn things over to you, Elton.
We're going to be talking about, hello, how are you doing? So thank you very much for joining me today. I'm going to be talking about Docker on Windows. So today's session will cover from the basics, so using what containers look like, how they work on Windows, through to taking a .NET application and running that in a container and seeing where that takes you. So let me share my screen here. Okay, so here's my screen up. So I've got some slides to go through. There's lots of demos. As we said, this all will be recorded. All the demos are on GitHub, and at the end of the session, there's some links to take you to so you can go and see what I've been doing. I'll answer Q&As at the end, but if I don't get time, we will do a blog post afterwards, and if your question doesn't get answered today, we will answer it in the blog post. So stay tuned to us on social media. So here we go. So there are two parts to today's session. So firstly, there's the basics, the introduction to what Docker looks like on Windows. I'll talk about Docker itself and Windows containers, and then I'll talk about the common workflow, which we call build, ship, and run, which is how you take your applications, package them to run in Docker, and then run them in containers wherever you need to run them. And then the second part will be about taking .NET applications and putting them through that workflow. Okay, so a brief history of computing. So in the beginning, we had servers, and if you wanted to run a distributed application, you did it by deploying things on different servers. So if I had a database, a web application, a console application, and a database, I'd run them all on different servers. And that way I got isolation, so they didn't interfere with each other. And if my database was using all my RAM, it didn't affect the website. The problem with that, of course, is it's horribly inefficient, and all these different servers are not being fully utilized. So you'll typically find that applications don't have the same resource profile. So my database might be memory heavy, but my web application is CPU heavy. Well, they could reside on the same box if I could guarantee the apps wouldn't interfere with each other. So we moved from having everything on separate expensive servers to having virtualized servers. So we put all our applications on separate VMs, and we ran the VMs on a big physical server. And the idea with that is I've still got my isolation, so my apps are still separate from each other, but I should be getting better density because I'm using one set of physical hardware. And what happened then was, turns out that isn't a very good way of getting density. So we've got as well as having our applications, which is all we really care about. All we care about is the application layer. We've now got a physical server to look after and 3 separate virtual machines to look after. So we need to look at the operating system, updates and patches, management of all those separate things, and we still didn't really get the utilization. So most data centers that are now fully virtualized, they still only get sort of 10% CPU utilization across the board. Okay, so the next step was virtualization at the app level, which is where containers come in. So with a containerized environment, your server, which could be a VM or a physical server, you just deploy one thing, which is Docker, and everything else you need, you run through Docker. So if you're going to run, in the case of a .NET application, if you're running IIS and ASP.NET, you don't need to install those things on your server. You're going to run all your applications through Docker. So if I've got my distributed app, I'm going to have my website, my console application, my database. They're all running through containers, and I'm going to run them all through Docker. So inside each of those things, which is just a container is just a boundary around a set of processes. Inside each of those containers, it looks like the app's got its own server. So each of those application containers has got its own host name, it's got its own IP address, and it looks as if it's got its own server. But actually what's happening is the processes that are running those applications are running natively on the server. So what we get is we get the density that we never got with any of the other models. So each of those processes is using the raw CPU power, and the containers can use as much of it as they need. They're not fighting over RAM or CPU, but they've still got isolation between the different containers. So I could have different versions of Windows, different versions of .NET, and the apps don't interfere with each other. Okay, so that's the basics for what Docker is. Docker is really easy to get started with. So if you've never used Docker before, these are the 4 things that you need to understand, which you will do by the end of this session. The first is the Docker file. A Docker file is a really simple script that you describe how to deploy your application. So you go through all the steps that you need to deploy the app, and that's written in a really simple language that you'll see a lot of, and that's the single way of encapsulating how your application needs to be deployed. And then you take that Docker file, and Docker runs through it, and it builds this thing called an image, which is like the binary output of the Docker file. It's a single package that contains your whole application. It's got everything from the version of the operating system that you need, it's got your application framework that you're using, it's got whatever dependencies you've got for your app, and your application binaries, all bundled into one thing. And then the way you share that, so when you build your image, that will live on whichever machine you've built the image from the Docker file on. When you share it, you push it to a thing called a registry, which is just a server that understands Docker images. And so you can share your versioned applications in these images on a thing called a registry, and then whoever's got access to that registry can pull down your image and run your application. And they'll run the application in a container, which is that virtual environment, that thin boundary around those few processes that make up your application. Okay, so let's just show you how that looks with a demo to start with. So let's get out of here. So on my machine here, I've got Docker installed. This is a Windows Server 2016 machine. To run Docker containers on Windows, you need either Windows Server 2016 or Windows 10. Those are the bare minimums. So I've got a recent version of Docker installed here. And what I'm going to do is just run some simple containers and get you up to speed with how this stuff looks. So if I clear my screen and if I do a Docker container run, so I'm telling Docker to run a container, and I'm going to put it in the background. There are different ways to run containers. I can run a container that just does one thing and exits. I can run an interactive container that lets me connect to it as if it was a remote machine, or I can run a background container, which is like a Windows service. So I'm saying detach this, so run it in the background. And what I want to run is Microsoft/IIS. So of these parts, Microsoft/IIS is the name of the image, and there's enough information there for Docker to go and grab it from a registry if I didn't already have that image. So you can run this on your own machine, and you'll get exactly the same output. So when I run that, I get this big long ID back, which is the container ID that Docker generates. And now I've got my container running. So if I look at my running container list, I've got, oh, that one didn't start, so let's try that again. So I've got 80B is the container name. So let's have a look at my list. I've got 80B here, that's the name of my container. It tells me various bits and pieces, like when it was created, what command it's running inside the container, how long it's been up, and what ports it's on. So it's listening on port 80, but it's not publicly available. The way I started this container, I can only access it from the machine that the container is running on. So inside here, if I look inside this container, I can do Docker container inspect with the container ID. And I get a whole stack of information about this container, including the name of the image and any environment variables that are specified in here, and a whole bunch of stuff. And the thing I'm interested in is the IP address. So this is the container's internal IP address. I can only use this from other containers on my machine or from my machine itself. But if I'm logged onto the machine, I can browse to that IP address, and that's IIS. So that's not particularly impressive, but what I've done there by running my Docker container run command, this command here, I've started IIS in the background, and I haven't had to do anything to get IIS up and running. So this is an image that's owned by Microsoft. They've written a Docker file that tells you how to deploy IIS on top of Windows Server. They've built it into a Docker image, and they've shared it on Docker Hub, which is the free public registry. So anyone with Docker running on Windows can run that exact command, and they'll get the exact same output. Their IP address will be different because that's a random thing that Docker generates, but when they look at their own IP address, they'll see the exact same output. Okay, so if I clear this down, the other one I'm going to run, just to show you how this looks, is I'm going to run SQL Server which I've already started here. So a similar command, there's a few more things to add in here. So Docker container run, same as before, and detach to put it in the background. I'm giving it a name so that I can refer to it later on. And the name of the image is Microsoft MS SQL Server Windows Express 2016 SP1. So it's a nice long image name which tells you exactly what's inside there. And the bit after the colon is like a versioning scheme. You can put whatever you want in there, but what Microsoft have done for this image is they're telling us that it's Windows SQL Server 2016 and it's Service Pack 1. There's a couple of other things that I've passed which this particular image needs. So it needs environment variables to be surfaced inside the container, which Docker does when it starts the container. You have to pass these in, otherwise this particular image won't start. So inside the Docker file for SQL Server, and that's on GitHub, you can go and check that out. There's a script that starts when the container starts, and it expects to find this flag set to yes, so to say you accept the license agreement, and it expects to find a default password for the administrator account, which is what that value there is. So if you don't pass those in, it won't work. When I run this now, the output will be the same, it's just a random container ID. And if I have a look at my container list now, I should have them both running. So I've got my IIS container, I've got my SQL Server container. I don't have SQL Server installed on this machine, and I wouldn't need to ordinarily have it because this is a development box. So this is a great way for non-production environments to run a database without having to download SQL Server and install it and make sure it's the right version that matches production or anything like that. Literally, you run this exact command, and you'll have this version of SQL Server running on your Docker environment. And just like before, if I go and inspect this container, I can get the IP address. I can either use the ID or I can use the name that I gave it. So I'm going to use the name, and there's a whole bunch of stuff like before, including the IP address. Now this is a SQL Server container, so it's got SQL Server running inside, and I can connect to it just like it's a remote SQL box. So if I lose this connection, so this is a SQL client that's it's an open source SQL client. If I pass the server address as my container address and I connect on port 1443, I'll put in the password that I provided when I started the container. Make sure I spell that correctly. Docker-call43. And now when I connect, I'm connecting to the SQL Server running inside the container. So I've got the master database and tempdb and all the usual things you get with an empty initial setup of SQL Server. And I can go create a database here and create tables and populate data and all that sort of stuff. As far as my client is concerned, it's just SQL Server. I could use SQL Server Management Studio to connect to a Visual Studio or another container or another application that isn't in a container. This is just a remote SQL box that happens to be running inside a container. Okay, so that's the quick demo to show you how the simple side of this stuff works. We'll be doing some more interesting stuff a little bit later on. So Docker on Windows, well, Docker started in the Linux world, and this idea of putting a thin boundary around a few processes and calling it a container, the mechanisms to make that happen have been in Linux for something like 20 years. But it's relatively new to Windows because it came in Windows Server 2016. So when the Microsoft team were looking at building the new release of Windows Server, at the same time that they were speccing it out, Docker was becoming massively popular in the Linux world. And the Windows Server team wanted to have similar container functionality in Windows Server. So the Windows Server engineers and the Docker engineers worked together for 2 or 3 years to make that happen. And we've had Docker support in Windows Server now for the last 18 months. It comes with the production support. So on Windows Server 2016, you can run Windows containers in production and get support from Microsoft and from Docker. So when you run this stuff in Windows, you're going to have, if you're familiar with Linux containers, all the concepts are the same. So you're going to have your operating system installed, and that's all you install. You don't need anything else to run your application images because all the things the application needs comes from the Docker image. So on Windows, you run Docker as a Windows service. It sits there in the background, and when you want to run something like a web application, you run it in a container, but the actual process is running natively on the host. And it's the same in Linux. So in the Linux world, you would run Docker as a daemon, so a background process that's always there. And if you want to run a web server, you run it in a container, and the actual process is running natively on the server. So that's fine, and that running the process natively on the server is what gets you the density and means you can run an awful lot of containers on your server. But it also means that you can't do this. So you can't take a Docker image that's built for Windows and run it on Linux, because that Docker image has got a specific operating system's file system, so a Windows image will use NTFS, and it's your specific operating system's mechanism for starting processes. So inside the IIS Docker image, when you start the container, it expects to be able to run a Windows service to start IIS. Now, if you try and run it on the Linux server, it's got no idea how to access the file system, and if it did, it would have no idea how to run a Windows service. So the whole process model is different. So you have to match the container image with the operating system that you're running on, and that's the kind of base requirement. But Docker itself is cross-platform, so these two Dockers that you're seeing on the servers there, it's almost entirely the same code base. So Docker's written in Go, and there are parts that say if I'm on Windows I need to do this, and if I'm on Linux I do this, but the vast majority of it is a single code base. And the way that the Docker command line works is when you're running a Docker command, like the ones you've just seen me run, that command line talks to a REST API, which is what the Docker Windows service exposes, or the Docker Linux daemon exposes. So your command line talks locally to a back-end API. And what that means is you can point to a different machine. So from a Windows box, I can control a remote Linux server running Docker, or a remote Windows Docker server. And similarly, if I was on my Mac, I can control a remote Windows box or a remote Linux box. And so the API is cross-platform. And while you can't run Windows containers on Linux or Linux containers on Windows, you can combine a bunch of servers into a single unit, into a single cluster. So you can install Docker on a bunch of Linux servers and a bunch of Windows servers, join them together, and then treat them as a single cluster. We call that a swarm. So in swarm mode, you can have a variety of servers, some Linux, some Windows. You could even have a cluster with Raspberry Pis and IBM mainframes in the same thing, because they all speak Docker. And what you do there is you set some up to be the managers who control everything, some of the workers that run the actual containers, and then externally you just connect to the cluster as a whole, and you talk to the whole cluster, and you say these are the apps I want to run in containers, this is the service level I need, and so on. You treat it as a single unit, and you don't really care which servers are running what. Okay, so that's the kind of basics of how Docker containers work on Windows. And as I've said, the core things that you may be familiar with from the Linux world, the idea of images, the idea of registries, those things are all the same. It's just the base operating system that has to match. So if I'm using Windows inside the container image, I have to run it on a Windows host. Now, the core workflow that people use in Docker is build, ship, and run, which is on the back of all the t-shirts. And the idea is you build your application into a Docker image. So you package up everything you need into that Docker image. You ship it by sharing it on a registry, which could be a public registry if it's open source software, or it could be a private registry that's inside your own enterprise that you condition who can use it. And then whoever's allowed access to it, they can run that application by starting a container. So that application could be a database like I've just shown you, or a simple web application, or a more complex application. So the workflow is the same as it was on Linux. Okay. So what are the parts of that look like? Well, the build part is a command, Docker image build. So you're going to run that on your laptop, or you might run it on a CI server. And what the input to that is the Docker file. So we'll see a few Docker files later in the session. So the input of the Docker file it's a script that describes how to deploy your application. And it's in the Windows world, it'll be mostly PowerShell. So you're going to describe all the things your application needs to run. But it's not like a deployment document in Word, which is a human document, which is open to interpretation and potentially full of errors and out of date. The Docker file is how your application gets built, so it has to be correct, otherwise your application is not going to work. So what you do in your Docker file is you describe all the things that your application needs. So you'll start by saying, if this is the case of a .NET web application, you'll start by saying I need Windows Server at the bottom here, and then I need to install IIS, I need to install a particular version of the .NET framework, I need to install ASP.NET on top of that, and then right at the end, I copy in my own web application. And all these are written in a simple language in the Docker file. Then you pass that to the Docker image build command, and Docker executes all the steps inside that Docker file. And the output is an image, which logically is just one very big file that contains the complete file system of your application. One particular version, it's like a snapshot for one version of your application. And then wherever you built it, that's where the image currently is. So in order to share that with someone else to run on a different server or to run on a cluster, you need to do Docker image push. And that takes the local image and it shares it on a registry, which could be Docker Hub, which is the public registry. It could be your own private registry. It could be an open source registry, whatever you've currently got running. And then to execute your application, to start an instance of it, you do Docker container run, just like I've currently done. And then that starts the app in a container. So that container has got the full file system that you put into the Docker file that got built into the image. So inside that container, it looks exactly like it was built from the Docker file. And the only thing is that the actual process that's running is running natively on the host. So when I did my Docker container run Microsoft IIS, that's the end of the pipeline. Somewhere before that, someone at Microsoft or a process at Microsoft has done a Docker image build, and what they're building is a Docker file that describes how to deploy IIS. Okay, and wherever you run that container, it's going to be the same. So if you do a Docker container run Microsoft IIS or whatever image, if the image isn't available locally, first of all, Docker will pull the image down, so it gets a copy of the image to its own server, and then it runs the container. And whether you're running on a server or a virtual machine in the data center, or your laptop, or a VM in the cloud, it's going to be exactly the same. Because the application is completely bundled into the image, everything it needs, the configuration, the dependencies, is all there. It'll behave in exactly the same way everywhere. Okay, so far the couple of simple containers I've showed you were other people's containers, and now I'm going to quickly demonstrate how that build, ship, run process looks by building some of my own containers. So again, all the source goes up on GitHub, and I'll share that with you at the end of the session. What I'm doing here is I'm taking some parts out of a Windows workshop that we do at our conference, DockerCon. I'm just going to do certain parts of it to give you a feel of how this looks. So I've got an application here that is an existing application that already generates an artifact to deploy. So in this case, it's a Windows ASP.NET app, and it generates an MSI. So I've got an MSI here, which is the input to my Docker file. So this is a really good example of a situation where I've already got an application with a CI process or some sort of build process, and I want to see how that app runs in Docker. And I don't want to have to spend a whole bunch of time writing a complicated Docker file. They never really get complicated anyway, but I just want to take what I've currently got, run it in Docker, and see what I get. And this is a really good example of that. So what this Docker file does is it says start from Microsoft ASP.NET 471. So the words in blue are the Docker file instructions. There aren't very many of those, and they're pretty simple. There's only about a dozen that you need to learn to have a production-grade Docker image. What the from command says is this is your starting point. But you have to start from somewhere, which could be a fresh install of Windows Server, or it could be something that's got other things already installed on top of it. And what I'm starting from is an image that Microsoft owns. It's got ASP.NET 4.7.1 installed. And when Microsoft released their images, they use a long and complicated tagging system. So the tag after the colon is the version of this image. And this tells me it's 4.7.1 version of .NET. It's running on Windows Server Core, which is Windows Server 2016, but without the UI. And this is the exact version of Windows Server that it's running on. So there's a monthly release of Windows, which you see with your Windows Update and your patches. And when there's a Windows patch to deploy, Microsoft also rebuild their Docker images. And so this is pinning me to a specific version of Windows with all these bits installed. The next line is the shell command, and shell just says, for the rest of the Docker file, I want to use PowerShell, because by default with Windows, it will use the ordinary command line. So by having that shell command in there, any instructions that I run, I can use PowerShell. The entry point command is telling Docker what to do when you start a container. So when I build this image, the image is a snapshot, it's a static thing. Wherever I move that around, it's going to be the same everywhere, because it doesn't change. When I start a container, Docker needs to know what process to run to start my container. And in this case, there's a simple PowerShell script that Docker will run when the container starts. Then the copy command, this will run from wherever I run the Docker image build. So it will expect to find a file called bootstrap in the local directory, in the same directory as the Docker file. And it's going to copy that bootstrap file into the image, and that's what's going to be run when the container starts. And then the next thing it does is it copies in the MSI. So it copies in the Windows installer that I've already generated from a different process. And the last thing it does is it deploys the MSI. So I'm using MSI exec. I'm doing an unattended install with a quiet and a no restart. and I'm wrapping it in a PowerShell process. So start process at the beginning and then the wait flag at the end to make sure that the package is fully deployed, that the Windows installer process has a chance to complete. So this would be the Docker equivalent of your current deployment document, the one that starts by saying we need to commission a new server, you need to install IIS, and it will have 5 pages of information about IIS, and then install ASP.NET and 2 more pages about that, and so on and so on and so on, until you eventually say copy the MSI from this network share, double click the MSI, and then click on this button 5 times, all that sort of stuff. This gets rid of that. It's actionable, it's precise, and it's the way your application is going to get built. So that's my Docker file for this version of the application. So the bootstrap that I want to package, which is my startup command, all it does is it copies some environment variables from the level that Docker sets them to the level that Windows uses, and then it runs this little app called Service Monitor, which is part of the Windows image that I'm using. And all that does is it starts the Windows process for IIS and makes sure it carries on running. So it's just like a liveness check to make sure that process is still running. And in the same directory, there is the MSI. So if I want to build this, let me copy the path, clear this down. I just do a Docker image. Oh, let's go to the right path to start with. So that's where it is. 1.0. And oh, there's all my stuff. So I just do a Docker image build, and I give it a name. The name is the tag. It's the name of the image. But if I want to share it, I need to give it something that identifies it as me. So I could call it anything I wanted to, but if I want to share it on Docker Hub, I need to use my Docker Hub user ID, which is 6side. So my user ID is 6side. I'm going to call it 6side / signup web v1 1.0. Okay, so what that's going to do is it's going to execute all the steps in the Docker file. So we'll see this happening now, or I need to tell it where the Docker file is, which is the local directory, which is that dot there. So that's the last thing I need to do. So I've already built this when I was doing a dry run, so that's why I've got all these cache operations. So I'm going to run it without the cache, and then I'll explain what that means. So just to show you how long this actually takes. So this is executing now. Each line in the Docker file gets executed one at a time, and then the output of each line is a separate part of the image. So I said that the image is logically one very big file that contains your whole operating system and your application and all its dependencies, etc. Physically, it's stored as smaller files, and those smaller files are they're called layers, image layers, and there's a layer for each instruction in the Docker file. So what Docker does is it looks at the input for each Docker file command. So it looks at the files that are being copied, it looks at the Docker file instructions, and it generates a hash to uniquely identify the input to that particular Docker layer. And if it finds a match in its cache, so it's already built this image, then it will use that layer from the cache. So when I ran it the first time, it went through and everything came from the cache because I'd already previously built it. This is one of the things that makes this so efficient, is that the image format is broken down to these small layers that can be shared, and they're small so they're easy to distribute, and they're cached, so if there's a match for another application or a similar application, then you'll use the cache, so it's all very fast to run. Okay, so that's built my application. So what that's done is it's taken my MSI here and it's deployed it inside my Docker image, and the output is that image which I can use to run my application. So this is a good starting point, and this is fine. Like, Docker doesn't mandate how you do this, and this option is perfectly good to get you up and running. The problem with this approach is that the Docker file is meant to be your explicit instructions of how to deploy your application. And if you're just going to use an MSI, then you lose a lot of the detail that could be there. So this MSI could be doing anything. It's not even necessarily a .NET web application. I assume it is because I'm using the ASP.NET image, but the MSI could be doing anything. MSIs can have custom actions that run, that could be doing literally anything, and it's not clear to me from looking at the Docker file what this application actually does. So I need to have extra knowledge. Whereas when you write your Docker file, that's your chance to put all the knowledge in one place. So if I want to run my application, this application is a web app that uses a SQL Server database. So I could start a database container like I did before and make sure I give it the right name, and then the web container would use the SQL Server container by using its container name. But rather than do lots of separate commands, if you want to run a distributed application, you use another tool from Docker called Docker Compose. And what Docker Compose does is it lets you describe a distributed app. So in my case, I've got two components in my application. Each of them will have had a Docker file to build the image, but now I'm saying how I'm going to run the containers together to form my whole application. And there are two parts here. There's a database, and I'm just using Microsoft SQL Server Express image, the same image that I've already run, but this is going to run as a new container specifically for this application. I'm setting that, accepting the license agreement again, and I'm passing it a file that contains my password. And the second part is a web container, which is my web image that I've just built. And that's going to use the database. So it's got a dependency on my database container. It's using the same environment file to get the connection string with the password in it. And it's exposing port 80, which means traffic can get into the container on port 80 from wherever it's running. And they're both connected to the same Docker network. So Docker has its own kind of virtual network concept, and containers that are on the same network can access each other by their name. So inside my application here, there's a connection string for the database, which is expecting to find a database server called SignUpDB. And when the web container tries to find that server using the DNS name, Docker will respond and give it the container's IP address. And that's how these things can reach each other on the Docker network. Okay, so to run this, I just need to go and browse to my folder where the compose file is. Where am I now? I'm in there, so I'm going to go back a couple of levels. I'm going to go in here. Here's where all the compose files are. These are for all different evolutions of the app. I'm just going to pick out a couple of ones to show you today. So I'm going to do Docker Compose, and the file I'm going to use as the input is version 1.0. I'm going to run up-d. And what that does is it takes the file as the desired state. So that's the final state that it's going to get to. And what Docker Compose does is it looks at what's currently running in Docker. It looks at what's described in the Docker Compose file, and it will do whatever needs to happen to make that desired state. So in this case, I wasn't running anything from this application, so it's created both parts. It creates the database first, because that has the dependency, and then it creates the web application. So now I should have a whole bunch of things running. I've got my original containers that I ran IIS. I've got my original SQL Server container that isn't connected to anything. And I've got my new SQL Server container that's going to be used by my new application, my new web application that I've packaged with my MSI. So let's go and see what the IP address is for that one. So if I look at, let's spell this directly, if I look at this container, which is A55, and get the IP address, I can browse them out. Now this could be, in this case, it's just a fairly current .NET application, but it could be a .NET 3.5 application. It could be going back anywhere, because the Windows Server container has got backward support for way back to like .NET 2.0 from, it could be currently running on a Windows Server 2003 machine, and I can package it to run in Docker, and it will work like this. Now this obviously doesn't work properly, and what I should be able to do at this point is say, well, this is the container IP address. This is an error message from IIS. So what I'm saying is there's nothing listening at the root. So however this is deployed, the web application must be in a virtual directory. So what I should be able to do is go and look at my Docker file and say, let's see how the web application is deployed, but I can't see it in here because it's all in the MSI. So this is one of the downsides of an MSI. Just by looking at the Docker file, there's not enough information for me to start using the application. So what I actually need to do is I need to go and look at how the MSI got built, which is way down in here somewhere. There's a setup directory, and there's an XML file using Wix, and this describes how it's built. So all I need to do is scroll through these hundreds of lines of XML, and way down here somewhere, here we are, here's the virtual directory. So the alias is signup. So this is the problem that I'm illustrating here. So I've got two deployment mechanisms. I've got the MSI, which is this horrible, complicated XML description, and then I'm using that inside my Docker file, whereas I could be just using the Docker file, and it would make it a lot clearer. But for now, when I browse to sign up, that's going to kick into my application. Now, what this is doing is it's hitting a cold instance of IIS. So when the container starts, it runs IIS, which sits there in the background, and just like if you turn on your server with IIS, it doesn't actually start a worker process to process requests until the first request comes in. So this is the first request that's hitting my application. It's starting the worker process. This particular application uses Entity Framework code first. So it's connecting to the database. It's finding that an empty database schema, because I was just using Microsoft SQL Server Express, so I would have had an empty database. It's deployed the schema. It's deployed a bunch of reference data, and then the application connects. So because I'm using, the other downside of using a really simple approach to having my Docker file is that I'm not getting any real benefits from the platform. So what I could do in a more complicated Docker file is I could do the warm-up for me, and I can make sure that when the container is running, it's ready to receive requests. I'll show you that a little bit later on. So here's my demo application. It's nothing of any interest at all. It's a fake newsletter application. The tool is real. So Play with Docker is a real tool that you can go and use, and you can run Docker inside a browser. It's really cool. But this is just a fake application to sign up for a newsletter. So when I click in here, these drop downs are all coming from the database. So my web container is talking to my SQL Server container, and if I put some data in here, and I put app. And this doesn't ever get validated, so I don't really need to put anything in here. When I click on Go, that's going to insert a row into the database. So that's my basic application, which I've just got started with by running an MSI inside my Docker file. So it's a really quick and simple way to see how your app looks in Docker if you've already got some sort of artifact, like an MSI or however else you're deploying it. So that's up and running. Now that data is being saved inside SQL Server. So I could go and, let me have a look here. If I have a look at my container list again, this is the new one, 85B. So if I do a Docker container inspect, 85B4, this is the IP address of my new SQL Server container. So it's a completely separate container. They're both running at the same time. So my existing SQL Server box is still there, so I can still talk to it, and I can go and set up a new connection, or I can just edit this connection and connect to a different SQL Server machine. I happen to be using the same password. So if I connect, then I'll see I've got a sign-up database here, which is what the web application deployed using Entity Framework. And inside there, I've got a prospects table. And if I select that, that's the data I've just put in. So I'm connecting to SQL Server inside my container, just as though it were a remote database. And I can connect to it from a SQL client, again, just like it's a remote database. It happens to be a container on my server. Okay, the last thing to do, so I've done the build from my MSI in my Docker file. I've done the run. If I want to share this, then I need to ship it. And the way I do that is by pushing the image. So right now, that image that I've just been running, so let's show the list again, this image here only lives on my machine. And if I want to make that available for anyone else, or for you to download and run it yourself, I need to share it on a repository. So I've already signed in here using my 6-side account. So I can do a Docker image push, give it the name of my image, and it will push all those layers up. Now the layers that I talked about, these things here, these are all the different outputs of my Docker file being built. So some of them come from earlier on in the process, and some of them come from when I've just been building my Docker file. I'm not going to finish this because that's 60 odd meg. So you just have to take my word for it. That would push them all up, and then you'd be able to pull it down yourself. Actually, this already exists, so you can go and download this if you want to. Okay, so I built it from an MSI, I pushed it up to Docker Hub, and then I ran it using Docker Compose. But all Docker Compose does is start containers. It's just a nice way of defining a complex distributed system. So they start off pretty simple like this, where I've got my database and my web application, and all I'm actually defining here inside Docker Compose is the command I would use for Docker container run. So I'm setting environment variables, I'm saying what image to use. That's all I'm doing now. Okay, so that was the simple part. So we've seen how what containers look like. We've run some really simple containers, and then I've built an application into a Docker image myself, my own application running in Docker. I've seen it's really easy, but using the MSI approach, it's got me started quickly, but there are limitations. So the second part of what I'm going to talk about is how you can use Docker to modernize your application. So what we've done so far, taking an old app, running it in a container. If that's an app that's being regularly used but isn't being worked on, so there are no new features coming, it's not being actively developed, putting the MSI in the Docker file running the application in a container, that might be all you need to do. Because by doing that, it becomes portable, and I can take that image and I can run it in the cloud, any cloud. I can run it on my data center, I can run it on physical servers or virtual machines. So if I've got an application that's sat on Windows Server 2003 and I want to get it off there and run it in Azure, I could script it to run in one of the PAL services that runs in the cloud, or I could run the MSI in a Docker file and take that image and run it in any cloud. So by having it in the Docker image, it makes it really portable. And that might be where it ends for a particular application if it's not being actively developed. For applications which do have a roadmap and they are still being worked on and there are still features being deployed, moving it to Docker is the starting point to then go and modernize the architecture. If it's an old monolithic application, it's really easy to break features out and run them in separate containers. And there are some really well-established patterns for connecting containers in efficient ways. So just very briefly here, because I want to save some time for the Q&A. I'm not going to do all these things, but these are all in the workshop content, which I'll share with you at the end. So imagine I've got my web application that you've just seen. I've got a website, I've got a database. If I want to run that myself as a developer, if I've just joined the team, I'm going to need the source code. I'm going to need the version of Visual Studio that everyone else is using. I'm going to need the version of SQL Server that everyone else is using. And it's probably going to take me 2 or 3 days to get all my setup ready before I can actually work on the thing. And then every time that there's any drift, so if somebody installs a newer version of something on the CI server, then all the developers need to get in sync, otherwise things start to break in strange ways. So that's where we currently are before you move to Docker. Version 1 is kind of like what I've just shown you, where I have my application running in a container, talking to a database container. Now, in this case, I've built the application with an MSI, but if I could build it from source code instead, and then suddenly I don't have a dependency to match all my tools with every other developer and with the CI server, because the tools all come in with the Docker file, which I'll show you shortly. Now, once I've moved to Docker, that gives me a really nice opportunity to start breaking things out. So if I were to evolve my application, this is my web apps talking to a database, I might want to break out some of the back-end features, and I could put a message queue in between. So instead of my website directly inserting data into SQL Server, I could publish an event onto a message queue, which is the green container, and then I'd have some other process that's listening for events being published to that message queue. And in this case, it would be a .NET console application that when it receives an event, it does the same to SQL Server. And by doing that, I get a couple of things. Firstly, I've decoupled the web application from the database, so I can scale them independently. I could run hundreds of web containers, and if I was getting a huge amount of traffic from the internet, all that would happen is my queue would fill up, and it would take a while to empty. But then I could run more of my message handler containers to work through the queue. The second thing it gives me is it's giving me a way to add features to the back end. So I could break more features out and use the same pattern to publish events and have something reacting to them. So I could add a whole separate reporting database with an analytics UI and just tap on to that same event that's being published. And then so breaking out the back end with like an event-driven architecture is really straightforward in containers because you're going to deploy all these different components as containers. So as this architecture gets more and more complex, all I'm doing is adding more blocks to my Docker Compose file. So each of these things will have a Docker file. It might be a Docker file that I own, or it might be something that's public that I'm using from Microsoft or from whoever owns the message queue. And then I'm going to have a Compose file that joins them all together and defines my application. So it's a really nice way of, rather than saying, here's my architecture, it's a monolith, I want to go to microservices, it's going to take 2 years and there's very little business benefit at the end. Instead of doing that, you can look at specific features and take that feature out into its own container. And that's going to help you actually deliver business value with each new release. And the other thing you can do, so I've looked at the back end here with the message queue. The other thing you could do is you can start to break out the front end components. So instead of having a monolithic website, I could take maybe the home page out and run that in a different container. And why would I do that? Well, maybe that needs to change more frequently than the rest of the app. So if business users want to roll out a new version of the home page, get some quick feedback and see whether it's more popular than the previous one, that's difficult to do if you've got a huge monolithic application that's got a 2-week regression testing cycle. But if you can take a small feature out, and that's the feature that the business wants to change regularly, then when they want to do an update, you just test that little feature. You don't have to do a full regression test. And it really helps you to drive the agility by saying that we know we're not going to damage the rest of the application because we're not deploying anything else. We're just deploying the small feature in one container that we know we've tested. Okay, so that's how this application evolves throughout the whole workshop. What I'm going to do is I'm going to skip back to a version where I've just got my application talking to a database, but I'm going to be using source code to build it rather than MSI. So I've shown you the disadvantages of the MSI, and now I'm going to show you the alternative, which is building from source. So inside this folder, I've got all the source code for my application, which has got my website in there. It's an ASPX website, so it's a web forms application. It's running .NET 4.7, but it's migrated from originally 3.5. So all the source code is there, and all the Docker files are here too. And for version 1.2, this is the Docker file. And it's got a little bit more going on. It's a little bit more involved, but it's a more production-ready Docker file. So the language is the same, so I'm going to start from a specific version of Microsoft's image with ASP.NET installed. And then I switch to PowerShell so I can run PowerShell commands in the rest of the Docker file. And then what I do in this run command is I'm just running PowerShell scripts. I'm just running command that's here to remove the default website. I'm going to create a directory, which is where my web application content is going to live. And then I'm creating a new website, give it a name, specify the port that it's using, and then specify the actual directory where the content is going to live. So already you can see this is a much better way of deploying your application, because you can look at this and say, okay, it's a web app, it's running on port 80, I can see where the content lives, and you can start, it's easy to start using this application. All you need to look at is the Docker file. So I'm going to skip this just for a second, go down to here to the entry point. The entry point is the same as before. When you start a container, it's going to run a script, and that script is just going to make sure the Windows service is up and running and it stays up and running. And then I copy in that script from the external location. Now all the content, which is going to be copied into my web app directory, comes from a published website. So I'm using like web deploy here to compile my web project into a folder that contains everything. So it contains the binaries, the content, the CSS, the ASPX files, everything's in one folder. And I'm doing that in the same Docker file. So at the top of this Docker file, so I'm looking at the middle of it now, at the top of this Docker file, there's another from statement. So there's a from statement at the beginning here, which has got this from Docker samples, web builder, as the images to use. And there's a final from statement, which is my actual application image. So this is called a multi-stage Docker file. If there's more than one from statement, there's many stages, and Docker runs them all. So it runs them all in a single process when you build the image. So the image that I'm starting from has got MS Build installed and the web deploy package and the targeting packages for .NET 4.7 and all that stuff. So it's got everything I need to build a .NET 4.7 ASP.NET application. So this is the equivalent of having a new agent for my CI process that's got everything it needs to do to build an application, but it's already captured in a Docker image. So I'm using that image to compile my application. And then what I do is I create a working directory, and then I copy in my NuGet package config. So I'm just copying in one file from the source code on my machine into the image, which happens to be my NuGet package config. Then I do a NuGet restore, and then I copy in the rest of the source code and do MS Build. And what that does is I'm taking advantage of that image layer that Docker has. So my NuGet package config won't change so frequently as my source code. So if I don't change the packages and I do a Docker image build, it will use the NuGet layer from the cache, and it will only build this when I'm changing source code. And then right at the end, it's going to copy that compiled application into my final image. So all the stuff that's in the first stage, MS Build and web deploy and all that stuff, doesn't get into the final image. The final image is just the ASP.NET image plus my published web application, so my content, not any of the actual build tools. The other thing I've got here is a health check, which is a simple command that tells Docker how to check the container is healthy. And what this does is every 5 seconds inside the container, this PowerShell will run. It will, and it just pings the local host. So it just does a fetch on the local host, and then if the status code is 200, it tells Docker everything's fine. And otherwise, it tells Docker things are not fine and this container is not healthy. There's a couple of reasons why that's good, but I'm running low on time, so I'm going to get through and build this now. So in order to build this, I need to be at the root of my directory. So because I need to access the source code, which is in here, and the Docker file, I need to be at a common root directory where they both are. And I'm going to build this, so I've already got this in here, as 1.2. Okay, so this is the same Docker image build command. I'm tagging it as version 1.2 of my image, and I'm telling Docker where to find the Docker file. So it's from this path, it's way down there. And inside the Docker file, I've got the relative paths to all my source code. So when I run this, it's going to send all the source code and everything to Docker, and then it's going to go through and execute all my commands. So it's doing all the things that I've just shown you. And I haven't previously built this, so it's not coming from the cache. So it's copied in my NuGet package config. Now it's doing a NuGet restore, so it's getting all these things from NuGet, and then it's going to do the MS build, and it's going to compile my application. And it's the MS build step that will generate the web deploy package, and that's going to be the thing that gets copied into my final application. So all the stuff that's happening here is only going to be it's happening inside a container, and it gets used by the final stage. But all the rest of the tooling that gets used doesn't go into my final application. So I've got two separate images that I'm using to make my application build. The reason why this is really cool is suddenly your whole application development becomes portable. So when you've got a Docker image, then you can run your application in a container. Wherever you run it, it'll be the same. So your runtime is portable. With this approach, everything's portable. So literally all you need to build this application from source is my Git repo. You pull the Git repo, you need Docker installed, and then you can do the same command, and it will do everything that you need. You don't need Visual Studio, you don't need MS Build, you don't even need .NET installed. All you need is Docker, and then everything else happens in containers. So this is eminently portable. And if I run this in 6 months' time, when my development environment has moved on, I've got a newer version of Visual Studio and all the rest of it, this will work in exactly the same way. Okay, so here's my version 1.2. Now to upgrade my application, I've got another Docker Compose file in here. So I've got Docker Compose 1.2, and it's the same apart from the fact that I'm using the version 1.2 of my image. And the way I deploy it is the same as before. So I do up-d, and I'm going to deploy version 1.2 instead. Oh, I need to go into the right directory. So like I said, what Docker Compose does is it looks at the file as the desired state, and it compares it to what's currently running. My database definition hasn't changed, so it leaves that as it is, but my website has changed because I'm using a new image now. So what I will do is I'll inspect this new container. So it's a completely new container using the new version of my application that I've built using MS Build. And if I browse to this now, then I'll see the new UI. So again, this is now hitting an application that's warming up, but the health check had already kicked in to warm it up a little bit. So it's got a new UI, it's got a very discreet advert for DockerCon that's coming up in San Francisco in June, but the rest of the UX is the same. So this is early on in my modernization process. This is, I'm going to work on this app and break features out, but I'm going to start by building it all in Docker and then using a single Docker file. And then from here on in, I can start breaking components out, because every time I need to rebuild my application, I'm just going to do another Docker image build. So this is the foundation for moving on and breaking down that monolith. Okay, so that was the last demo. So there are some things that you need to take away from this stuff before we get onto the Q&A. The three things that are core philosophies of the Docker platform: simplicity. So, but this stuff isn't actually all that hard. So the Docker file describes how to package your application, and the Docker Compose file describes a distributed application. It tells you how to run all the components in your application. I've shown you some simple examples today. They don't get much more complex than that. So a Docker file, for a production-grade Docker file for a container that you're going to run in a production swarm, in a production cluster, it might have 15 or 20 lines. Like, that's it. The Docker Compose file is a really nice syntax. It's really clean and easy to pick up, and you can break up your Compose files into different environments and then join them together. So you can kind of have overrides that say this applies to all environments and that only applies to a certain environment. So it's very easy to have an easily maintainable thing that the devs and the ops team work on together. So the second thing is independence. So when you've compiled your application into a Docker image, you can run that on any container system. So I've talked about Docker Swarm, but there's Kubernetes, there's Mesos, there's Service Fabric from Microsoft. Some of them don't have Windows support yet, but they all will have eventually. And they all run Docker containers. So if you invest effort in moving to Docker, you're then going to be able to run your application in a container wherever you want to. So all the clouds support Docker containers, and increasingly more of the on-premises orchestrators are supporting Windows containers too. And that last one kind of ties in with that, the openness side of it. So the image format, the registry format, they're all open standards that anyone can build tools around, and all the key parts of Docker, they're all open source too. Okay, so that's the bulk of the presentation, and here are the course of action. So the source code that I showed you, that's from that workshop, which is the Dockerly link, Dockerly Windows workshop. You can go and follow along with that. It's all up on GitHub, all the source code's there. There's a lot of words around it that you can follow through and see what it's all about. There's a video series, which is where I go into more depth on how you would do a modernization program using Docker. And if you want to try Docker Enterprise Edition, there's a trial.docker.com that you can go to. And you can catch up with me on Twitter, where I'm tweeting about this stuff all the time. So I have completely failed to look at the Q&A so far. So let's see if there are any ones that leap out on me.
Yeah, we have quite a bit of questions, so thank you everyone for submitting your questions. We won't be able to get to all of them because we are almost at the top of the hour. So Elton, as you're scrolling through, if you want to maybe pick one or two to answer, and then I don't know if you'd be willing, I could send you these questions. Maybe we can answer them offline because there are quite a bit, as I mentioned, but we only have about 2 more minutes left in the session. Can you see those questions? And do you see a couple you want to pull out and address?
Yeah. There's a couple of good ones that I'll answer straight away, and then the rest we'll put through into a blog post where we can talk about what we talked about today. So there's a good one here about performance counters. So are there performance counters inside the container like there are when you normally run Windows Server? And the answer is yes, there are. So all the normal Windows performance counters are there, and any custom ones you add are there too. And that's how you can, I won't go through it all now, but you can expose those performance counters to Docker, and it can scrape up metrics about all your containers. And those metrics can include things like CPU usage and memory, but also all your custom performance counters. So that's a really good way of getting metrics up into Docker. And I'll do one more, which is about where is the application or database data stored? So is it inside the container or outside? So it depends on how you run the container. So when I ran that SQL Server container, the way I ran it, I didn't specify what to do with the storage. So the files for my database lived inside the container, and they have the same life cycle as the container. When the container dies and gets removed, those files are gone. The other way to do it is by using something called a Docker volume. And a volume is a separate storage location, which could be on your server or it could be some sort of remote storage unit. And what you do then is that the volume has a separate life cycle to the container. So I run my container, it's writing to the volume, and if I replace the container with a new version of my app, the data's still there, and the new container can use that data too. So I think that's probably all we've got time for, and the rest we'll go and put them in a blog post.
That would be great. So we will take the questions that weren't addressed today, and as Elton said, we will get them in a blog post. So thank you all for posting those questions and joining. This does conclude the webinar, and just a reminder that this session was recorded, and a copy of that recording will be sent out to you all in the next few days. So thank you again for joining. Please make sure to check out events.docker.com for upcoming events, and we hope to see you in the next webinar. Thank you so much, and have a great day. Bye-bye.